Thank you for your interest in the OLI Stream Analyzer software. In these series of tutorials, we will show you how to use the software as well as customize it for your particular use. In this particular tutorial, we're going to look at the removal of nickel from a wastewater stream. To start, we're going to click on the Add Stream icon in the Explorer view of the software. You'll notice that in the left-hand window, we've added a Stream 1 name. This is a text field which can be renamed as necessary. In this particular case, we're going to rename it and call it Nickel Waste. The key I pressed there was F2. You also could have clicked on the Description tab and renamed it here at the top. We'll go back to definition. We're starting off by adding nickel hydroxide. So I will just click in the white box here and type in nickel hydroxide. And then I will click in the value field, and you'll see that the name has been renamed to nickel 2 hydroxide. This is what we call the display name. And we'll be adding 0.002 moles of the material. We default to water being in the stream, and it defaults to an initial value of 55.5087 moles. This is 1 kilogram of water. You can change the units by clicking on the units field, and we can scroll up to see kilograms, and you can see that it is 1 kilogram. I'll go back to moles to be consistent. I'm also going to add 2 titrants, which we'll use later. I will use hydrochloric acid. It'll have no value initially, and I was pressing the tab key there to move along, and sodium hydroxide. Okay. I actually find the display names to be inconvenient, and I will turn them into formula names. At the top of the program is the menu line, and in the middle is the word Tools. We'll change the Tools to Names Manager, and this will display the ability to change our name, and I'm going to click on the formula tag to change it into chemical formulas. I'll click apply, then OK, and you can see that the names have been renamed. I will then add a calculation. The button over here on the right is the calculation button, and there are 3 types of calculations: single point, surveys, and chemical diagrams. These series of tutorials will go through each one of the calculation types in great detail. For this example, though, we're going to click single point, and we essentially get the same screen. We have over here on the tree view the name called single point 1. This is the default, and we're going to rename it. I'm going to right click it this time and select rename and type in the word isothermal. That's just a name to remind me that this was an isothermal calculation. Over here on the right-hand side, we have the types of calculations that can be performed. We have isothermal, isenthalpic, bubble points and dew points, vapor amount and vapor fractions, set pH, precipitation points, composition points, and custom points. We will step through all of these in the subsequent tutorials. Right now, we're going to remain at isothermal. The temperature is 25 degrees and at 1 atmosphere. So the question we want to ask ourselves, what is the solution pH? So we'll go ahead and click calculate. And we've completed. I can scroll down the summary window here and see that the pH is actually 8.36586 or thereabouts. There's additional information that we can find. If I click on the Report tab, I can get additional information, much more detailed information about the stream. Here we have the aqueous properties of the stream. The pH again is reported, the ionic strength, osmotic pressure, electrical conductivity, and viscosity of the stream. Some bulk phase properties are also reported. Phase flow properties are reported. Scaling tendencies, which we'll talk about later, and the actual components in this stream by phase. And I can slide it to the right to see a little more detail. I can also see the output by clicking the Output tab here on the definition. Then I need to right-click to see additional information. This screen is partly cut off, but I'm going to look here, additional stream parameters, and once again I see the pH is 8.36586. Okay, we're now ready to see the response of pH to the nickel waste stream. What we're going to do is we're going to click back on the top level stream here where it says nickel waste, and then we're going to add a new calculation, and we're going to add a survey. You can see that the icon in the tree view has changed slightly, and it now says survey 2. It's the second object under this object nickel waste. There are several types of surveys that we can perform. Temperature is the default, but we can perform surveys in pressure, composition, and pH. For this example, we're going to select pH. What the program will do is we're going to take this stream, which contained nickel hydroxide and water, and add either an acid or base to adjust the pH and then plot the results. In the middle of the diagram, we have a box called Calc Parameters, and the acid and bases are unspecified. Also, you notice that the Calculate button is grayed out, which means we require additional information to proceed with the calculation. To do that, we'll click the Specs button, and we'll pick the acid and base titrants. In this case, we'll pick hydrochloric acid and sodium hydroxide. We could also add a new titrant that's not on this list by clicking the New Inflow button. We won't do that for now. We'll click OK. You can see under the Calc Parameters that we've got an acid and a base, and the Calculate button has turned green, and we're ready to go. So we'll just go ahead and click that button. The program calculates very quickly. The individual points are stored at the bottom of the screen on these tabs. I can also go into the tree view on the left and pop open all the individual points. Just like with the isothermal case, I can go into a point and get the detailed information about this particular point. This point 1 of 15 has a pH 0. That's one of the points we fixed. Plus we have some additional information about how much acid was required to reach that pH. Remember, the initial pH was 8.3. I'll click back on Survey 2. We can also plot this information. So I click the Plot tab. This is the default plot of the dominant aqueous species in solution versus the variable that was adjusted, in this case pH. This diagram is not really that informative, so I'm going to remove some of the items. To do that, we'll click the Curves button, and what we have here is the dominant species on the y-axis and pH on the x. So I'll get rid of dominant aqueous by highlighting it and clicking the left arrow button. I've now removed it. What I really want to do is plot all the nickel ions in solution. So that would be the aqueous. So I'll just scroll down until I find a nickel species. There's nickel plus 2. There's nickel hydroxide aqueous, nickel chloride, nickel hydroxide, and nickel hydroxide with 3 hydroxides. At that point, I just click OK, and you can see the diagram has changed. Most of the information looks to be buried in the x-axis, so we need to change it to expand this, and the best way to do that is on a log basis. To change the plot options, I can either right-click on the field or click the Options button. I'll select the Option button for the moment. Here I can change the plot displayed to some degree. What I'm going to do is change the y-axis and click on the logarithmic scale and apply. Then OK. Now the diagram has changed considerably. I've expanded the y-axis to log scale. I can see the effect of pH on all the ions. I can grab my legend and drag it out of the way. So let's look at this diagram for a bit. The blue squares are the nickel ions. And you can see that they're highlighted in the legend above. This is the pH and the Y coordinate. And you can see as we increase pH, the nickel ion decreases in concentration. Some of the other ions, this light green line, is the nickel hydroxide anion, and as we increase the pH, it becomes more and more strongly complexed, and it appears. Okay. The question is, why is this happening? Well, it's probably because we're forming some other material in this region of the diagram. And one of the things to look at, are there any different phases that are appearing? And most likely in this scenario, it's possibly a solid phase. So I'm going to click the curves button again. And this time, I'm going to close the aqueous and open up the solid. There's a button called Dominant Solids, and I'm going to put it on the Y2 axis. And we can see that this now blue curve appears, and it is the nickel hydroxide solid. And it appears in the same region where these ions are crossing. So it is precipitating out of solution. If I don't like the diagram, I can click Options again, and this time click the Y2 and also make it logarithmic. And we can see that it appears and becomes dominant in this high pH region. So if we were going to try to remove nickel from solution and to maximize its removal rate, we'd probably want to get to a pH of about 10 to remove the nickel from solution. The last thing that we can do is to rename the survey. And actually we'll go to the definition tab, description tab, and this will call it pH survey without additives. And in the description we could enter base case pH survey, no additional complexes. And now we have a little bit more descriptive information. In the next tutorial, we're going to go on and add a complexing agent to this solution. Okay, we're going to add one additional wrinkle to this survey. We're going to add a complexing agent, in this case hydrogen cyanide, which is a strong complexer with nickel, to see how it affects the pH response. I also hate to type, so what I'm going to do is do a trick. What I've done is I've closed the tree view for the pH survey, and you can see that as I mouse over it, it says pH survey without additives. That's the full name. What I'm going to do is I'm going to right-click it and select Copy. I'm then going to go to the top of the list, back to nickel waste, and select Paste. What it's done is it's basically copied all of the information without the results. You can see that there's no check mark here. Check marks indicate that this particular object has been calculated. So that I can make a quick modification to it without having to retype. I am going to change the name, however, and here it's pH survey with the complex. I'll now click on the definition tab, and I'm going to add a complex here of HCN, and I'm using the tab key at 0.01 moles. Now what I'd like to point out is that since I've added it at the calculation level, this component, HCN, does not appear in the other objects. So if I click quickly back on the original pH survey and its definition, you see there's no HCN. If I click on the isothermal case, once again, there's no HCN. So it's only in this particular case. Everything else is set up. The acid bases are the same. It's a pH survey, so I'll just press the Calculate button. Right now I'll just go right to the plot. And we can see that the plot has changed dramatically. The dip here is much lower, although it's approximately the same pH. If you're having trouble seeing the diagram because of the legend, you can just right-click and click Hide, and the diagram goes away. The legend, rather, goes away. If I want to see what the stream is, however, I can still mouse over it, and that's the nickel ion. Now, this blue curve is the nickel-nickel cyanide complex. It's a solid, and it appears at very low pHs, about a pH of 4 or so, which is here. Remember, the solid before was nickel hydroxide, and it's not present. This is the dominant solid, and it's being plotted on the Y2 axis. I might want to look at why is this dip here, and am I missing something? And I'm going to go back to curves, and this time I'm going to get rid of all the species, and I can actually select all of them at once. I used the shift key and selected them all, and now I got rid of them. And I'll pick dominant aqueous, and the curve is slightly different. I have this brown curve that's the sodium ion. Of course, we're using sodium hydroxide to adjust things. That's the neutral HCN. That's hydroxide ion, and so forth. The problem with this curve now is that the sodium ion is dominating the graph, and sodium is uninteresting, so I'm going to get rid of it. And once again, I'm going to pick all the nickel species. And plot it. Now what's different is this blue circles. This is an ion complex of nickel cyanide as indicated in the legend. It's a very strong complexer, and in fact, for all the nickel species in solution, it's the most dominant species in solution, even more so than the nickel solid, which are now these X's. I find that confusing, so I'll get rid of the dominant solids. And we can see a little clearer diagram. So that was how to perform a pH survey and how to plot. Once again, here's the plot button, and we can see many more things to plot, and we'll take a look at them in various tutorials. The last thing I wish to do is to get rid of all of my ions once again, and select a new type called MBG aqueous totals. This stands for Material Balance Group Aqueous Totals. If I open the tree, I can look at the nickel. This is the sum of all nickel species in solution. And there it is, my diagram. And you can see there's a dip. One last thing I'm going to do here is I can now create a template, and I'm going to save this template. It gets saved in a default folder, and you can see I have plenty of templates stored already. This is going to be MBG nickel versus pH. And the reason I bring that up is I want to look at the same diagram in the case without the complex. And I'm going to go to template and apply it. I'll find the one I just created, and there it is, and click apply. And you can see that the same graph, the dip in the total amount of soluble nickel is at high pH, yet with the complex is at low pH. And so we can go back and forth very quickly to determine where the best place to remove nickel would be in terms of pH. We're now going to save this application. We use the File Save button, and we can store it anywhere. This is the default folder. I've actually created a different folder. And I'm going to save this That's nickel hydroxide pH survey. I can now recall that at a later time. Subsequent tutorials will use this same file. This file will also be available on the website at the link indicated below. Thank you.